Hello students, welcome to this lecture. In this lecture we are going to study some CBSE pattern questions and their solutions of the chapter differential equations. So you have to revise all the concepts of differential equations, the various applications which we did, and then you can attempt the questions and see, cross check with the solution which I will give you. First question is of 1 mark and it says determine order and degree if defined, of differential equation given below. So if you see this differential equation, this is of the first order derivative, this is of the second order derivative. So this second order derivative actually determines the order of the differential equation. So the order of this differential equation will be equal to 2 because highest order derivative is 2. Now what is the degree? Since all the derivatives are in the polynomial form, we can define the degree. Now degree of this particular derivative is 4 and for this is 1. We won't take 4 because it is first order, second order is this. So the highest order derivative, its highest power we take. So the highest order derivative is only 1 here and its power is 1. So we will say that its degree is actually equal to 1. So this is how we will define the order and degree for this question. This is a 1 mark question. So very straightforward question based on the definition of the order and degree as we studied. Let us come to the next question. This question is also of 1 mark. It says that verify that the given function is a solution of the corresponding differential equation. So here two things are given to us. Firstly, we have been given a equation and another is given a differential equation. And you have to say or verify that this is the correct function for this differential equation, or you can say that this is the solution of this differential equation, or you can say this is the differential equation formed from this equation. So let us check. The term y dash is being used here. So we have to first find y dash. So if you want to differentiate this y, this will become y dash and the right hand side will become x cos x plus sin x. We will apply a product rule of differentiation and we will get this. Now after getting this y dash, let us check left hand side of that differential equation. So left hand side is x y dash. So after taking as this as y dash, we will get x square cos x plus x sin x. This is left hand side. Now let us come to right hand side. Right hand side of the differential equation is given as y plus x root over x square minus y square. Now we know that y is equal to x sin x. So we can say this is x sin x plus x root over x square and this is x sin x. So x square I am taking common, this will become 1 minus sin square x. Can we write it as x sin x plus this x will come outside, this will become x square. 1 minus sin square x is cos square x, so this will become cos x. So can we say that the left hand side and the right hand side are equal? Yeah, of course these two are equal. X sin x plus x square cos x, x sin x plus x square cos x. Okay students, next we will come to the third question. This question was also of verification, very simple question, 1 mark. Let us come to the next question. Third question is of 2 marks. It says form a differential equation. You have to form a differential equation representing the given family of curves by eliminating arbitrary constants a and b, and this is the differential equation which is given to us, and we have to form this is the curve which is given to us, family of curves for arbitrary constants a and b, for which we have to form the differential equation. So here there are 2 arbitrary constants. Okay students, so if there are 2 arbitrary constants, how much times we have to differentiate it? 2 times. Second order derivative should be the final equation of the differential equation for this curve. So first we will differentiate it. Since it is y is equal to e to the power x a cos x plus b sin x, when we will first time differentiate it, we will get y dash is equal to e to the power x minus a sin x plus b cos x plus e to the power x is the differentiation of e to the power x into a cos x plus b sin x. So the product rule we have applied over here. Now we will write it on simplification like this. that e to the power x is common. Sin x here and here will become b minus a sin x. And what about cos x? Here it is b, here it is a. So a plus b cos x. So we will add them. This is y dash. We will differentiate it again. So this is the first function, and derivative of this will become minus a plus b sin x, and derivative of this will become b minus a cos x. Then we will add, derivative of this is e to the power x, and keep this term as it is. Again we are applying the product rule of differentiation. B minus a sin x will be this term. So this is y, this is y dash which is present over here. This is actually y dash, this is your y, and this is your y double dash. This whole is your y double dash. So what we do first, we simplify this y double dash, we write it as e to the power x common, and cos x here and here, b minus a and a plus b will become 2a, 2b actually, 2b cos x, and if we add this with this, we will get minus 2a sin x, minus 2a sin x, right students? Okay, so this is y double dash after simplification. Now what we will do, we will write, let me write it over here, here it was only the calculation part. So if we multiply y with 2, you have to do this analysis after seeing y, y dash, and this is y double dash. So what you do, you take twice of y and add it to y double dash. What will happen? This will become twice of e to the power x into a cos x plus b sin x. This will become twice, which will come outside. You can take this 2 outside from here. So this will be 2e to the power x b cos x minus a sin x. So when you will multiply this with 2 and then add with this, 2e to the power x is the common part. A cos x will be here and here b cos x. So it will become a plus b cos x. Okay students? Now b sin x is here, which will become twice as we are taking 2y. So b sin x, and here it is b cos x, minus a sin x. So b minus a sin x we will get here. So what we see, that 2y plus y double dash, this is your y double dash in its simplified form, 2y plus y double dash is actually giving this. And if you analyze this particular function over here, this is e to the power x a plus b cos x plus b minus a sin x, same as y dash. Here only 2 is multiplied. So you can say this is nothing but 2 of y dash. Then that means that y double dash plus 2y is equal to 2 times of y dash. So what you will do finally, let us erase all these calculations now, as we have formed the differential equation, and we will say the differential equation formed is finally in its proper form, y double dash minus 2y dash plus 2y is equal to 0, is the second order differential equation formed of the given curve, that is y is equal to e to the power x a cos x plus b sin x. Okay students, so this was a little lengthy question and it was of 2 marks. So there was not much of technique involved here. It's straightforward. You have to know that you have to differentiate it 2 times because it is a second 2 parameters here, so second order, and then you will eliminate those constants by manipulation. Next question is of also 2 marks. It says form the differential equation of the family of circles having center on y axis. So its center is on y axis and radius 3 units. So any circle which is having center at y axis means its center is 0 comma a, let us suppose, and radius is 3 units. So such circle would be a family of circle. This could be a circle or this could be a circle, all of 3 radius but having center on y axis. So such circle can be written as x square plus y minus a whole square is equal to 9, as the center is 0 comma a. We can assume that center which is varying here is 0 comma a on the y axis and its radius is 3 units. So since there is only one parameter here which is a, we will differentiate it only once. So when we will differentiate it, what will happen? this will become 2x, this will become 2y minus a into y dash is equal to 0. This will give you y dash is equal to, in fact take y minus a is equal to, that would be better, y minus a will be minus x by y dash. Why we have taken y minus a? Because this y minus a like this can be substituted here. So we can finally say, therefore, we won't differentiate it again because there was only one parameter, we will differentiate it only once, first order derivative. So x square plus y minus 1 is x square by y dash square. We will replace this y minus 1 here by minus x by y dash is equal to 9. So we can say that after LCM, y dash square x square minus 9 plus x square is equal to 0. After simplifying this, we say that x square minus 9 into y dash square plus x square equal to 0 is the differential equation formed when we find the family of all the circles having center on y axis and radius 3 units. Okay students, so this was a question which was of 2 marks again. Now we will move on to next question which will be of 4 marks. So next question is the 5th question. Find the general solution of e to the power x plus e to the power minus x dy minus e to the power x minus e to the power minus x dx equal to 0. So we can write this particular given differential equation like this. We will take, it is given as e to the power x plus e to the power minus x dy minus e to the power x minus e to the power minus x dx equal to 0. What we can do? We can take this term on the right hand side and divide dy by dx, and the right term here is e to the power x minus e to the power minus x divided by e to the power x plus e to the power minus x. Now let us write it as dy is equal to e to the power x minus e to the power minus x by e to the power x plus e to the power minus x dx. After taking that dx on the right hand side, integrate both the sides. What you can see here, that this term e to the power x plus e to the power minus x, if you substitute it as u, then what will be its differentiation? E to the power x minus e to the power minus x, which is already present in the numerator. So you can say the term over here is actually du. If denominator is u, numerator is du. So what will be its integration? Of course, log of mod u plus c, and here it is y. So you can say y is equal to log of mod u, and finally mod u will be written as log of e to the power x plus e to the power minus x plus c. So what you see, that the family of curve of the given differential equation is y is equal to log of e to the power x plus e to the power minus x plus c. Okay students, right, let us move on to next question. So we are touching all type of problems which can arise with different part of differential equations theory. Next question is of 4 marks, previous was 2 marks. Show that the given differential equation is homogeneous and solve it. How do we show that the differential equation is homogeneous? First we will write in the form dy by dx. So this is the differential equation. It is a very long differential equation. So what you will do, this dx will go in the denominator and this whole term will go in the denominator of this left hand side. So we can write that given equation is actually x cos of y by x plus y sin of y by x and multiplied with y upon, here the denominator will become y sin of y by x minus x cos of y by x is equal to, into x of course, is equal to dy by dx. So we have just separated the terms and written it like this. Next we have to show that it is a homogeneous differential equation. What is a homogeneous differential equation? It is a differential equation in which this whole term here is a homogeneous function of degree 0. What it means? If we replace x by lambda x and y by lambda y we will get this as a function of xy into lambda to the power 0, which will be 1. So this, and after substituting this, we will get exactly the same function as lambda to the power 0 is 1. So if we substitute x as lambda x, we see that here we get lambda x, here we get cos of y by x, because of course lambda y and lambda x will cancel, lambda will cancel both of them, plus lambda y sine of y by x again, outside it will be lambda y. In the denominator, if you see, this is lambda y, sine of lambda y by lambda x is y by x, minus lambda x, cos of y by x, when you put lambda you will get again y by x into lambda x. Is this same as this function? So let us see, this lambda get cancels, this lambda and this lambda will come out as common, this lambda will come out as common, and that lambda will cancel. So this function is now the same function as this. This function of x and y is equal to lambda to the power 0 function of lambda x comma lambda y. So we can say that this is a homogeneous differential equation. Now after finding that this is a homogeneous differential equation, what is the substitution we do? We put y is equal to Vx, from which we get dy by dx is equal to v plus x dv by dx. Therefore this differential equation will become, x we are not touching, y we are putting as Vx. So x will come out to be common, and this will become 1 cos y by x will be v. Of course y by x you will do, you will get v. Plus here you will get v, x is outside common, sine of v. Y is again Vx here, divided by, y is Vx, so v comes here and x goes outside, sine of v again as y by x is v, minus x, x has already come outside, so minus cos of v, and outside we have x, so we will write it as x is equal to dy by dx will now be written as v plus x dv plus dx, v plus x dv by dx. So after this, doing this substitution, y is equal to Vx, we get the differential equation, which is this one. Now let us try to solve this differential equation. First we will simplify it. This x will cancel, this x will cancel, and this will become purely a function of v. This is what happens in homogeneous differential equation. So this will become cos v plus v sin v upon v sin v minus cos v multiplied with a v outside, this v is equal to v plus x dv by dx. Now let us take this v on the left hand side, this v, and here it will become minus v. We will take LCM, and this will become cos v into v, and this will become plus cos v into v. So twice of cos v into v, 2v cos v, plus v square sin v, and when v come here, this will after taking LCM become minus v square sin v. So both will cancel. So in the numerator this is what it will come, v sin v minus cos v is equal to x dv by dx. Now the next step would be, you will separate the variables, of course. So you will write here dx by x, on the right hand side it will become v sin v minus cos v upon 2 remains here, v cos v goes here, dv. This is dv. So we integrate both the sides. This will become 2 log of x plus constant of integration is equal to v cancel, this will become tan v. What is the integration of tan v? Log of mod of sec v. And what will happen? Minus cos v by v cos v. Cos v will cancel, you will get minus 1 by v, which is minus log of mod v. So finally we can write whole of these things. After putting v is equal to y by x, this becomes log of x square plus c. This becomes log of, this comes in the denominator, it will become cos v, that is cos of y by x, and this get multiplies, this become y by x. Of course here it is a minus sign, so it will also come in the denominator. Actually this will be 1 by sec cos v, that is cos of y by x, and here it will come downside y by x, so upside it will become x by y in the numerator. So we have just used the property of log. This minus this is actually log of this divided by this, and we have substituted v as y by x. Okay, students. Now when we proceed further here, it is almost done now. We have to just rearrange. So this will be written as x square, and if we call this constant as log of a constant k, so x square into k, and we eliminate log from both the sides, is equal to x by y cos of y by x. So this will be written as x cancels, xy cos of y by x is equal to k dash, 1 by k, let us call it k dash. So this is the final family of curve which is obtained after solving the given differential equations. Okay, students, right. So now let us move on to the another question which is also of 4 marks, and now we are getting some difficult problems. So you have to know all the concepts, then only you can attempt it. Next question is, for the differential equation given below, find a particular solution satisfying the given condition 1 plus x square dy by dx plus 2xy is equal to 1 by 1 plus x square, where condition is given that when x is equal to 1, y is 0. This will help to find the constant of integration, and we will get a particular solution, a particular curve instead of family of curves. So this we will use later on. First we have to find that one. So we can divide by 1 plus x square here. This 1 plus x square over here will go in the denominator of other two terms, and the question will become dy by dx plus 2x by 1 plus x square into y is equal to 1 by 1 plus x square whole square. Now students, you have studied all the forms of differential equations, how to solve a differential equation. Is it variable separable? No. Is it homogeneous? Of course no. What else remains? Linear differential equation. Is it linear? Yes, it is linear. dy by dx plus py is equal to q, where p, q are either constants or function of x. So here there will be an integrating factor which we have to find, which is e to the power integral of 2x by 1 plus x square dx. Of course, when you take 1 plus x square as u, this term will become du. So its integration will be log of u, that is log of 1 plus x square. So this is e to the power log of x square. Now e and log will cancel, you will get x square as the integrating factor, sorry, 1 plus x square. This is not x square but 1 plus x square, this is u, 1 plus x square. So you get x square plus 1. This integrating factor on getting multiplied to this differential equation will give on the left hand side y into the integrating factor, and on the right hand side integral of this into this term, integrating factor into q. So 1 plus x square will cancel and you will get this. This will become tan inverse of x plus c after the integration. Now what was the condition? When x is equal to 1, y is equal to 0. So when x is equal to 1, y is equal to 0. This was the condition given, which will fetch us this as 0, this as pi by 4. So c is equal to minus pi by 4. So this was a general solution. What will be the particular solution for this differential equation under the condition 1 comma 0? So we will put c is equal to minus pi by 4 here, and we will get y into x square plus 1 is equal to tan inverse x minus pi by 4. This will be the answer for the differential equation which is given in the question. Now let us come to one more 4 marks question. After that there will be 6 marks question. It says find the equation of a curve passing through the point 0 comma 2. Here again 0 comma 2 point is given so that we can find the specific curve, particular solution. Given that the sum of the coordinates of any point on the curve exceeds the magnitude of the slope of the tangent to the curve at that point by 5. So let us first try to understand what question is saying. Actual question starts from here, given that. This is for particular solution. The sum of the coordinates of any point on the curve. What are the points on the curve? Variable point x and y. What are their sum of coordinates? X plus y. Exceeds the magnitude of slope of the tangent. What is the slope of the tangent? Dy by dx. And what is its magnitude? We take a mod here by 5. So this sum exceeds this value by 5. Now you have to find the exact curve of this differential equation which is passing through 0, 2. So here dy by dx modulus is there. So two differential equations we will solve. We will solve dy by dx. Let us write it here so that you will be more clear about it. So differential equation which is given here is actually two differential equation. X plus y minus 5 you take on the right hand side, and dy by dx mod is on the left hand side. So when you will remove this mod, here there could be a minus sign also, there could be a plus sign also. So you have to solve two differential equations. So I will solve one differential equation. Similarly, you will solve another differential equation. So I will solve for plus. Another differential equation will be for minus, of course. So this is dy by dx is equal to x plus y minus 5. Now this curve is also passing through 0, 2, which we will use later on. Let us write it like this. Let this x plus y minus 5 is equal to t. What it means? 1 plus dy by dx, this is 0, is equal to dt by dx. So this dy by dx will be written as dt by dx minus 1, and x plus y minus 5 will be t. So we will say this on the right hand side, t plus 1, take in the denominator, so dt by t plus 1, and dx will go on the right hand side like this. Integrate both the sides. So when we will integrate this, we will get log of mod of t plus 1 is equal to x plus constant. Now we have to put t as x plus y minus 5 because nothing called t was given in the question. So log of mod of x plus y minus 5 is equal to x plus c. This will be the family of curve for that particular differential equation whose word problem was given. Now it is passing through the point 0, 2. So if we put x is equal to 0, log of 0 plus 2 minus 5 mod is equal to 0 plus c. So what we'll get here? It is t plus 1. So there is a plus 1 also here. Sorry for that. X plus y minus 5 is t plus 1 also. So there is a plus 1 also here. So this will be log of minus 3 plus 1, that will be minus 2 mod. And of course minus 2 mod will be 2. So c is equal to log of 2. But one thing which you have to understand from here, that after putting the point x comma y as 0, 2, which is lying on this curve, we are getting this particular quantity, this particular value x plus y minus 5 plus 1, which is inside the mod, as a negative value. Because when we put x is equal to 0 and y is equal to 2, this whole terms comes out to be minus 2. Which means when we eliminate this mod, we should take negative of that. Because for one point, if it is giving a negative value, for all the points in general, it will be negative, the mod will be negative. So we will say that let us write this general curve not like this, log of 5 minus 5 plus 1 is actually minus 4. So let me write for your convenience minus 4. So what we will see, we will not say log of mod of x plus y minus 4, we will say log of 4 minus x minus 5. So when we will eliminate mod, the signs will just become negative because this is a negative value, is equal to x plus c, and c we have obtained, that is log of 2, right students? So you have to understand these minor points, that is here we have seen that after putting the point this becomes negative. So when you remove the mod, you will take a minus sign. So it will become 4 minus x minus y. This will become 4 minus x minus y is equal to e to the power x into e to the power log 2 will become 2. So you can say this is the final equation of that particular curve which is passing through the point 0, 2, and the sum of the coordinates of any point on the curve is exceeding the slope of the tangent, modulus of the slope of the tangent, by 5. So this is what we obtain here. Now let us move on to next question, which is a 6 marks question. This says find a particular solution again of the differential equation x plus 1 dy by dx is equal to 2e to the power minus y minus 1, given that y equal to 0 when x equal to 0. So this actually condition is again for particular solution. First we have to solve this given differential equation. So what will be this differential equation, we have to see. Now here it seems that it is a variable separable, of course. So what we can do, the term of y we will take on one side. So it will become dy divided by 2e to the power minus y minus 1, and on the right hand side it will become dx by x plus 1. Now we will integrate both of them. So variable separable is applicable here, we have separated them. Now integrate. So what we have done, dy by 2e to the power minus y minus 1 is equal to dx by x plus 1. Now when we integrate, here what change we can do, let us multiply by e to the power y in the numerator and in the denominator. So this will become e to the power y, this will become e to the power 0, so 1, and this will become e to the power y again, right. Now it is easy to integrate. One more thing, if you consider this as u, this particular thing is minus du. When you differentiate this, 2 derivative will be 0 and its derivative is minus e to the power y. So with a minus sign, this term is actually du. So when you integrate this, you will get minus log of mod of u, which is equal to log of mod of x plus 1 plus c. What is u? You have taken 2 minus e to the power y minus log of mod of 2 minus e to the power y is equal to log of mod of x plus 1 plus c. Here also the similar situation is there. What to do when this mod will be eliminated? Should we write 2 minus e to the power y or e to the power y minus 2? Because mod x gives plus minus x according to the situation. So what should we write this? So we have been given that this curve is passing through 0 comma 0. So if we put x is equal to 0 and y is equal to 0, here when we put y is equal to 0, we get 2 minus e to the power 0, which is 1, as a positive value, which means we can eliminate mod and its sign won't change. So we can say that this is minus log 2 minus e to the power y is equal to log of mod of x plus 1 plus c, right students. Next what we will do, here also mod will eliminate with a positive sign only, because when we put x equal to 0, 0 plus 1 is 1, which is positive. So you have to understand that for x is equal to 0, it will get 0 plus 1, which is a positive term. So now what we will say, we have to also find the constant of integration, the parameter, to get the particular solution. That also we used to find by the curve, by the point through which it is passing, 0 comma 0. So for y is equal to 0, this becomes minus log of 2 minus 1, and here it becomes log of 0 plus 1 is equal to c. This is also plus c, this is also 0, and this is also 0. So what you find finally, c is equal to 0 eventually. So constant of integration is 0, which means that this equation can be written as minus log of 2 minus e to the power y is equal to log of x plus 1, and constant of integration is 0, which means let us take the power here, and this will become 1 by 2 minus e to the power y. Log will be eliminated from both the sides, this will become equal to x plus 1. Now it is only about simplification, you have got the answer anyhow. So you can say that 2 minus e to the power y is 1 by x plus 1. Now you can take e to the power y on the right hand side and this on the left hand side. So 2x plus 1 by x plus 1. This is what you will get after the simplification, and this is the answer for this particular question. Now we will come to the last question of this series, which is also of 6 marks, and that will help us to complete all type of questions which we come across. So this is the 10th question now of 6 marks. The population, this is a word problem, this is application of differentials. The population of a village increases continuously at the rate proportional to the number of its inhabitants. What does it mean? If suppose at any moment P is the population So rate of change of P with time, that is dP by dt, is proportional to the value P. dP by dt is proportional to P. As more is the population, more is the rate of increase. Less is the population, less is the rate of increase. So this is what they are saying. dP by dt, rate of increase, is proportional to the population present at any time t. If the population of the village was 20,000 in 1999 and 25,000 in the year 2004, what will be the population of the village in 2009? So first write the differential equation. dP by dt, rate of change of population, is proportional to P, which means dP by dt is equal to constant of proportionality into P. Let us do by variable separable, which is quite easy here. This will become like this, integrate. So this is ln P is equal to KT plus C. Now you have been given some situation like when the time was 999, then the population was 20,000, and one more thing is given, that when the time was 2004, so we will not say 1999, we will say the initial time, that is 0, and this is 2004, that means after 5 years the population has become 25,000. Now they are saying what will be the population when the time is 2009, that is the difference with the initial time is 10 years. So what will be the population? So when we put t equal to 0 here and P is 20,000, the value of C will come out to be 20,000. So this first condition helps us to determine the value of C. P is 20,000 and T is equal to 0, so C is log of 20,000 actually, there is a log over there. So T is log of 20,000. So the equation becomes log of P is equal to KT plus log of 20,000. We can write it like this, P is equal to 20,000 e to the power KT. After simplification, we take 20,000 to the left, P by 20,000 is e to the power KT. Now another condition is given, when T is equal to 5, the population is 25,000. So we will say now, using this here, that P is 25,000 when this is 20,000 multiplied e to the power 5 K. T is 5 after 5 years. So we can say that 25,000 by 20,000, that is actually 5 by 4. So log of 5 by 4 is equal to 5K, which means K is equal to 1 by 5 log of 5 by 4. So this is now the value of K which we have obtained. First we obtained the value of C, which was constant of integration. Then we obtained K, which is constant of proportionality. So both the constants we know by now. Now we have to find by the third condition that when time is 10 years, after 10 years gap, what will be the population. So the equation now become P is equal to 20,000 e to the power KT, and K has come out to be 1 by 5 log of 5 by 4 into T. So if we put T is equal to 10 years, after 10 years, what will happen? We will get 20,000 e to the power 1 by 5 log of 5 by 4 into 10. This will divide and give you 2. You can write 20,000 here, e to the power log of 2 will become the power inside the product which is inside the log. So it will become 25 by 16. Next step, this e and this log will cancel. So this will become 20,000 into 25 by 16. Now divide 20,000 by 16. What you will get? 16 1 16, 40, 16 2 32, and then 80 50, 1250. 1250 into 25 is 31250. So after 10 years, that is in 2009, the population is going to be 31,250 of the particular area. So these were some of the questions which were helpful in the understanding of differential equations and its applications. Thank you, students.